Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 2 to the power of x is equal to 0. Now what I'm first going to do is I'm going to take the log on both sides. So now I have log 2 to the power of x is equal to log 0. Now, if I have something in the form log a to the power of b, this is equal to b times log a, because I can actually move this exponent b to the front of the logarithm. So this is actually an important property of logarithms, and I'm going to use this property on log 2 to the power of x. So I'm going to simply move this x to the front of the logarithm. So now I would have x times log 2 is equal to log 0. Now we want to isolate x, obviously, so I'm going to divide both sides by log 2. So then these two cancel out, and I would have x is equal to log 0 over log 2. However, log 0 over log 2, this is equal to, first off, log 2 is equal to 0.301. However, log 0, this is actually undefined. Log 0 is undefined, meaning x is also undefined because you can't divide an undefined number over 0.0301. So this means that the value of x is undefined. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x plus 3 to the power of x plus 2 to the power of x is equal to 5. Now what I'm first going to do is I'm going to factor out 3 to the power of x from our left-hand side. So now we have 3 to the power of x times 1 plus 1 plus 1. Now this is equal to 5. Now 1 plus 1 plus 1 is 3. So now we have 3 times 3 to the power of x is equal to 5. Now I'm going to divide both sides by 3. So now we have 3 to the power of x is equal to 5 over 3. Now I'm going to take the log of both sides. And whenever I have a logarithm in the form log a to the power of b, I can actually move our exponent here, b, to the front of the logarithm. And this is known as the power property of logarithms. So this would be equal to b times log a. So now we have, I'm actually going to move this x to the front. So now we have x times log 3 is equal to, now log of 5 over 3 is the same thing as log 5 minus log 3. So now I'm going to divide both sides by log 3. So then these two cancel out, these two cancel out, and I'm left with x is equal to log 5 minus 1. And log 5, sorry, is for log 3. So now the value of log 5 is equal to approximately 0.6990, and the value of log 3 is equal to 0.4771. So now if I plug these in, I get 0.6990 over 0.4771 minus 1. And this means that x is equal to, if we simplified this, this would be equal to 0.4651. So this is our answer.